Before we start, do you remember when you would use the binomial distribution?
It's when no,
Man said it's when, and he doesn't know. Any ideas?
it's when you don't.
The binomial distribution is when it's a yes or no question because it's about a success or failure, like the probability of success and the probability of failure. So make
Yeah,
sure you go over that afterwards.
yeah.
The normal distribution isn't like that. You can use the normal distribution when it's about something with a range of outcomes.
It's like dice and stuff.
No, that's discrete when it's 1, 2, 3, 4, 5, or 6, a certain amount of
Oh,
unlimited. This is like unlimited outcomes from a certain range. So for example, people's weight,
oh,
it can be anywhere from like 20 kg or even like less if it's a baby
yeah,
until like 120 kg if it's like a muscle bodybuilder or something.
yeah,
And there'll be like an average weight, right? So let's say 60 kg is the average weight of the population or whatever. So it will look like that. The majority of people will be around 60 kg, and then it will be evenly spread throughout.
yeah.
So it's evenly spread about the mean. We'll see it come up in questions, but that's what you have to understand. You use it when it's about something that's evenly spread around a certain mean.
Okay.
The second thing is when we did binomial distribution, we wrote something that looked like this. We would write that X is binomial with N and P.
Yeah.
Yeah. N was the number of trials
P was the probability
of
of getting the outcome.
success. So now we have normal distribution. Okay.
Yeah.
So X is normally distributed with mu and sigma. Mu is the mean. Sigma squared is the variance. Okay.
Yeah.
And do you remember what the difference is between standard deviation and variance?
Variance was squared.
Yep. Standard deviation is the square root of variance.
Yeah.
Okay. Write that down quickly. X and mu sigma squared.
Go on.
X and mu comma sigma squared.
Yes.
Arrow mean and the variance. Quick.
Yeah.
All right, cool. So we can use this to work out probabilities. For example, here we have, it tells us that it's about how much a leopard walks. So X, the amount the leopard walks, is normally distributed, bracket, 62,
10.
variance is 10 squared.
Oh
100,
yeah.
but we like to write 10 squared.
Okay.
And then it says work out the probability that X is less than 80. So we never need to do any working out for this. We just need to know how to use our calculators. So what we'll do is we'll go to our calculator and we'll go to menu and we'll press
Probability.
number 7, which is distribution, and we'll put normal CD. Okay.
Wait, why is it not PD? Is it the same
PD is if
reason?
it's X equals 80. So whenever it's an inequality, then it's normal CD.
So is CD less than 80?
CD is more than or less than, or any
Okay.
range, but when it's specifically equals, then it's PD.
So it's different to when it's binomial.
Binomial is the same thing. If it's equal to, use PD. If it's more than or less than, use CD.
Oh yeah. Okay.
Yeah, but it's less than or equal. But anyway, here it asks us for a couple of settings. So we put normal CD. It asks us for upper. It asks us for lower. It asks us for sigma, and it asks us for mu. Okay.
Yeah.
So we know sigma is 10.
62.
No,
Huh?
the
Oh,
standard
sigma.
deviation is 10.
Yeah.
And we know the mean is 62. Okay.
Yeah.
For upper, we put 80 because we want everything less than 80,
Yeah.
and there's no lower limit. But we can't leave that blank, so we just have to put a really low number. So minus 1 million will work. Yeah,
Oh yeah.
it can be any really low number. Okay.
Yeah.
And then we get 0.964. Okay.
Yeah.
For the next question, it says that the amount of time to cycle, which is x, is, which is the squiggly line, normally distributed. So I write n, and then 17,8.
Yeah.
Probability x is more than 22 equals. I'm going to do normal CD. What would I put as my upper, lower, mean, and all that stuff?
Upper is 22.
No,
What?
lower is 22
Oh, so
because
would
it's
up
everything above 22.
so upper you can do any massive number then.
Yep.
And then the mean is 17.
Yep.
So then sigma is
Square root 8.
8.
No,
Yeah.
square root 8. Because in
That's
the
sigma squared, right? 8.
exactly, that's sigma squared.
Yeah.
Okay.
Yeah.
So we put square root 8 for sigma in the calculator.
Yeah.
The calculator will tell you to put sigma. But so you don't have to remember that, but you have to memorize that when you're doing it in brackets, you have to put sigma squared.
Okay.
And then you get when you do that, you get 0.03855. Okay.
Yeah.
Cool. Try this one on your own. For this one, we've got x is normally distributed, comma 77, 8 squared. Because the variance is 64.
Yeah.
We're working out the probability that x is more than or equal to 65. So we choose normal CD because it's not equals, it's an inequality. We put the lower as 65 because it's everything more than 65. Upper can be a really big number. And we use the mean as 77 and sigma as 8. And then we get the answer 0.933.
Yeah.
For the next question. So x is normally distributed with the mean of 14.5 and the variance of 7. So later we're going to put the mean as 14.5 and the sigma as root 7.
Yeah.
And our upper, so we're working out the probability that the height is less than 12. So the upper is 12 and the lower is a really low number. And then we get 0.17235 using normal CD. Okay.
Yeah.
CD just means cumulative. It's for any inequality.
Oh. Oh, okay.
One more. So we're going to do x n 460 10 squared. Probability that it's between 465 and 475. So mu is 460. Sigma is 10 instead of 10 squared.
Yeah.
Yeah. Upper is 475 and lower. So we actually have a number for lower and upper this time, 465. And then we get 0.2417. The next thing we'll have to do is that will give us the probability and we'll have to work out what value it's talking about. But it's equally as easy. So I'll just give you a couple of examples.
Okay.
So let's write down the distribution to get our first mark anyway, as always. So x n 40, comma what?
40 comma 8 root 8.
Bro,
8
what do you put
squared.
there? Yeah, you put the variance there. Yeah, don't forget. We
Yeah.
put the variance there. And if the standard deviation is 8, then the variance is 8 squared. Just don't forget
Yeah.
that. Okay.
Yeah.
Um, it says find the score. It doesn't say find the probability, it says find the score exceeded in 5% of the test. So the probability that X is more than a certain score
Yeah.
equals 0.05. Does that make sense?
Yeah.
Okay.
So when you put the numbers in the calculator, it equals 0.05.
Exactly. So we do the same thing. We go to our calculator and we go to distribution, but this time we put inverse normal CD.
Yeah.
So once we go to inverse normal, we're going to put the area as the probability. So in this case, the area is 0.05.
Okay.
We're going to put our sigma, which is 8. We're going to put our mean, which is 14.5. But this is where it gets a bit confusing. So in some of your calculators, you will have the tail. So you can put right tail and just answer the question.
Yeah.
If you don't have that option, the calculator automatically gives you the left tail. So this is not possible to answer. We have to work out the probability that X is less than a certain number equals 0.95 instead. So we change that and we put 0.95.
Oh,
0.95. And then we get an answer. 18 point, wait. I put the wrong mean. So when I put the mean of 40, I get the answer 53.2. Okay. So to summarize, you either put right tail and 0.05 or left tail and 0.95. That's all. That's the only difference.
okay.
So for question 2, let's start by getting 1 mark for writing down the distribution x n 502,5 squared. Yeah.
Yeah.
Then I'm going to do the probability that x is more than x equals 0.01. And then I use the right tail.
Okay.
Or I do the probability that x is less than a certain number equals 0.99. Does that make sense?
Yeah.
So if you have the special calculator, you can do either and you pick right or left tail. And if the calculator doesn't ask for the tail, it automatically does left tail.
Okay.
So for left tail, we're going to do inverse normal, upper, no, sorry, there's no upper and lower. We're going to put area, which is the probability, 0.99. We're going to put mu as 502, sigma as 5, and then we get an answer. Okay, so let's try 0.99. And we get 503.6.
Yeah.
Go and try that. The last question we can't do, so this question, then we'll go back to the other method with the other types of questions. So this one, you got x n 4.35 and then 0.4 squared. Probability that x is more than a certain number is 4% or 0.04. So the probability that x is less than a certain number is 96%. Okay. So for the area, we're going to put, and that's for left tail. For the area, we're going to put 96% or 0.96. And then for the mean, we're going to put 4.35. And then for the standard deviation, we're going to put 0.4. And then we get x as 5.05. Okay.
Yeah.
Cool. So far, we've worked out probabilities. We've worked out values from probabilities. And now there's a completely new method if the question says find the mean or the standard deviation. Everything we've done so far, the calculator has asked for the mean and standard deviation. So if we don't have that, we need to use a different method. So we have to first understand what the normal distribution looks like and what it is.
Yeah.
So you got a graph like that, where this value is the mean and it's got a certain standard deviation.
Yeah.
In this case, the standard deviation is 12, and we don't know the mean. We can't solve anything about this question if we don't know the mean or the standard deviation. So what we do is transformations of graphs to make it into a new graph so that it looks like this.
Yeah.
We want a new version of it where the mean is 0 and the standard deviation is 1. This red graph, so the blue graph is called the normal distribution. The red graph is called the standard normal distribution.
Okay.
So how do we turn the mean from mu to 0? All we have to do is minus by the mean. So all the data points, in this case, all of the times we just minus them by the mean, and then the new mean will be 0.
Okay.
And then how do we squash it to make the standard deviation 1? We just divide it, all the values by the standard deviation.
Oh,
That's it.
why is that
So,
just an equation?
yeah, and you have to memorize that equation.
Yeah.
To standardize the normal distribution, in order for us to solve it, we use z equals x minus the mean divided by the standard deviation. And
Okay.
then instead of using this and this, which we don't know, we use the mean as 0 and the standard deviation as 1.
Okay.
So in this question, we have x is normally distributed with an unknown mean and a standard deviation of 12. And we know that the probability that x is more than 94 minutes equals 0.025 or 2.5%, 0.025.
Yeah.
We have to change this into a standardized version. So we know that z is normally distributed as well, but the mean is 0 and the variance is 1 squared.
Yeah.
That's what we're going to do to this. Before we do it, ignore this step if you've got the right tail calculator, but if not, we have to change it. So we have to do probability that x is less than 94 equals 97.5%. Yeah?
Yeah.
Or 0.097, no, 0.975. Okay.
Yeah.
The percent button does work, so it's the same thing.
Yeah.
Then what we do is we write the probability that z is less than.
94.
Yeah. So what we're doing is, so I wouldn't write this, but this is to understand. We're minusing both sides by mean and dividing both sides by the mean. But we don't
We're
write
dividing it by the mean.
minusing by mean and dividing by standard deviation to both sides of the equation.
Yeah.
But we don't have to write that. We just write z straight away. Yeah. So z is less than 94 minus mean over the standard deviation.
Oh, okay.
And 94 minus the mean over the 12. Yeah. And that's 0.975. So you know how we used to work out x using the standard normal?
Yeah.
We're going to work out, instead we're going to work out 94 minus mean over 12. So we do inverse normal because we're working out the value, not the probability.
Yeah.
So we put area as 97.5%, left tail. We put the standard deviation as
Well,
no.
12 squared.
No. We put the area, tail, left, area as 0.975. or tail right area as 0.025. Okay.
Yeah.
And then we put sigma as 1 and
Oh,
mu as 0 because now we've standardized it.
yeah.
That's really important. Okay.
Okay.
So 1, 0. And we get an answer of 1.96.
Okay.
Once we do that, we can solve for the mean. We've got an equation. So 94 minus mu equals 12 times 1.96. So mu, yeah. So to get from this stage to this stage, we have to use the inverse normal. So pretend that this is an x, yeah?
Yeah.
You know where I just wrote the x there, yeah?
Yeah.
So this part is equivalent to working out x. So you know in the previous questions when it was like, if the probability is 97.5, work out x, we use
Yeah.
inverse normal. So I use inverse normal with all of this stuff.
Oh, yeah.
Okay,
Okay.
but the only
Yeah.
difference is now we have that extra step of having to work it out. So
Yeah.
because we worked it out with a different bunch of, so what you can actually do is if you want, you can write it like this. You can write probability Z is less than Z equals 97.5%. And then you get Z
Oh,
equals 1.96. But then you
yeah.
still have to remember 1.96 is not your final answer. Because we minus everything by mean and divided it by standard deviation, now we have to do 1.96 times by standard deviation, add by the mean,
Yeah. Okay.
kind of. Yeah.
Yeah.
So mean is 94 minus 1.96 times 12, which should be 70.48. It'll be best if you just go for another example, you understand it.
Cool.
So here we've got xn 7,500 sigma squared.
Yeah.
We know that the probability of x being less than 6,000 equals 0.05.
Yeah.
Therefore, the probability that z being less than a certain number is also 0.05.
This time we don't have to flip it. Like we don't have to do one minus, do we?
No, no. This is left hill
Yeah.
already. Yep.
Yeah.
So we're going to do inverse normal. We're going to do the area,
0.05.
0.05. We're going to put the sigma.
Where's the sigma? 0? Wait, yeah.
Sigma is 1
Oh,
and the mean is 0. Just picture it. It'll be easier to remember. It's like that, but it goes through the middle, which is 0.
oh yeah.
That's how you remember. And the spread is 1, basically.
Okay.
So you put 1 and 0 and 0.05, and then you get an answer of z equals minus 1.64. Then you have to remember that's not the answer. That would have been the answer if we minus everything by mean and divided by standard deviation. So what we
So
do is
now, yeah.
we do we do 6,000 minus the mean. Yeah.
Yeah.
So the equation, I'll just write it again. Z equals x minus mean over sigma. So we do 6,000 minus the mean of 7,500 divided by sigma would equal minus 1.64.
Yeah.
So minus 1,500 equals minus 1.64 sigma. So sigma is 1,500 over 1.64,
Yep.
which equals 912.
Yeah.
Yeah,
Yeah.
right. Go on, try one. I just want to quickly recap something important before we continue.
Okay.
Whenever it says find probability, you use normal CD or maybe PD. We've not seen any PD, but it's just easy. It's just if it says equals.
Okay.
Whenever it says find X given probability, you use inverse normal.
Yeah.
There's 3 scenarios. Scenario 1, we use the value to get the probability, that's normal CD.
Yeah.
Scenario 2, you use the probability to find X, that's inverse normal. And scenario 3, whenever we have to find the mean or standard deviation, then it's standard normal. And that's like by ourselves.
Oh.
Okay.
Oh, no calculator.
That's like with inverse normal in the calculator. It's the
Oh,
one we've
okay.
been doing just now, the formula,
On the graph.
this stuff.
Yeah.
Yeah. Yeah. So find the probability, just use normal. Find the value given the probability, use inverse normal. And find the mean or the standard deviation, use standard normal. So this question we have xn, the mean is unknown, and the standard deviation, the variance is 4 squared. And we know that the probability that x is more than 165 equals 0.005. So our calculator only does left tail. So we have to rewrite that and say that the probability that x is less than or equal to 165 equals 99.5, so 0.995.
Yeah.
After we've done that, we say the probability that x is less than, no, the probability that z is less than 165 minus mu over sigma
Equals.
equals 0.995 as well.
Yeah.
So z equals, and we work that out in our calculator, and we just write a note using inverse normal, area, so it's left tail area as 0.995. And what else?
The mean is
Yeah, mean as 0 and sigma as 1.
1, yeah.
Okay. And then what do you get?
2.56.
2.5758.
Yeah.
Yeah, 2.5758. And then you can work out the mean, because 2.5758 times 4 equals 165 minus mu. So mu equals 155.
Yeah.
Okay, next question. We have 1 mark for writing out everything. Xn, mu, and 15 squared. Then we can say that the probability that x is less than 113 equals 0.8. So then the
Yeah.
probability that z is less than 113 minus mu over
Sigma.
15 equals 0.8 as well.
Yeah.
So using inverse normal, where area equals 0.8, mu equals 0, sigma equals 1,
0.84.
z equals 113 minus mu over 15 equals
0.841.
0.8416. Yep. So mu equals 100. Okay,
Yeah.
good. Is it question 16?
Yeah.
Cool. So question 16 and 17 are important because it's the same thing, but with simultaneous equations. So we have xn. We don't know the mean and we don't know the standard deviation because it says to find the mean and the standard deviation.
Yeah.
We know that the probability that the probability that x is less than 6.2 equals
11.51.
yeah.
Oh,
And therefore, the probability that z is less than 6.2 minus mu over sigma also equals 0.1151.
yeah.
Okay, so 6.2 minus mu over sigma equals, we worked that out using mean 0, sigma 1, tail left, and area as 0.1151. Okay. So that's going to be labeled as equation 1. We have to repeat the same exact thing. So we have longer than this is this, okay? So if the probability x is more than 9.5 equals 3.59%, then the probability that x is less than 9.5 is also this one minus that,
Yeah.
which is 96.41%, so 0.9641. Therefore, the probability that z is less than or equal to 9.5 minus mu over sigma equals a certain number by doing inverse normal again, where mu is 0, sigma is 1, and the area this time is 0.9641.
1.8.
Exactly?
Yeah.
Cool. So we can say that 9.5 minus mu over sigma equals 1.8. Now I can form two equations. So I've got
Just made them both equal to mu, right?
6.2 minus mu equals minus 1.2 sigma, and 9.5 minus mu equals 1.8 sigma, right?
Yeah.
If I subtract the equations, I get
I think it's easier if you just substitute mu.
it should be fine. Your calculator can even do simultaneous, but
Oh.
I just wanted to write them the other way around because the second one's bigger.
Oh.
So now if I subtract the two equations, I get 9.5 minus 6.2, which is 3.3. Minus mu minus minus mu is 0.
Yeah.
1.8 minus minus 1.2 is 3 sigma. So sigma equals 3.3 divided by 3, which is 1.1. And then I sub it back in to get my mu, which is 7.52.
Yeah.
Next question, we get xn mu sigma. We have no idea. Okay.
Yeah.
So we've got two equations. the probability that X is more than 112, sorry, 122.
Yeah. It's 4.95.
Yeah. So then the probability that X is less than or equal to 122 is 1 minus that, so 95.55.
Oh, yeah.
Then we can work out Z. So 122 minus mu over sigma equals just make sure you write down what you're using. So you're using left tail area as 0.9505, mu 0, sigma 1. Okay, cool. And then do it again with the other statement.
Yeah.
So you've got this statement as well. So the probability that X is less than 93 equals 10.56%. So 0.1056.
89.44. 0.8944.
Wait, what?
What?
Wait, what?
Nah,
Oh, the next step?
yeah.
Oh, okay. The probability that Z is less than 93 minus mu over sigma equals that as well. So then 93 minus mu over sigma equals, what was it? You said it?
0.8944.
Yep.
8944.
Yep. Where we use area as 0.1056, mu is 0, sigma is 1.
1.25.
What are you doing now?
Why?
Wait, what? Wait, why did you minus it?
Wait, did we?
Oh, we didn't need that. I don't know why you said that part.
Oh,
So we go back, we do. So the answer for that is when you do 0.1056, 1 and 0, we get minus 1.25. And then we have two equations. Okay. Yeah.
yeah.
So we got 1 and 2. The first one's bigger, so I'll write 122 minus mu equals 1.65 sigma. And the second one is 93 minus mu equals minus 1.25 sigma. Okay.
Yeah.
So 122 minus 93 is 22 plus 7, so 29. Minus mu minus mu is 0.
Yeah.
And 1.65 minus 1.25 is 2.9 sigma. Sigma equals 10, mu equals 105.5. The last part of this topic is hypothesis testing. We don't do hypothesis testing off a normal distribution like a variable. We do it off the sample mean. So let's say we're doing the amount of distance a leopard walks, and we think the mean, so we think xn with mu and sigma squared. Yeah, we think it has a certain mean, but that's for the whole population of every single leopard. Okay.
Yeah.
Let's say we have 10 leopards and it has a sample mean. So x bar is sample mean, mu is population mean.
Okay.
Let's say the sample mean is like 12 or 10 or 9 or 8. Okay.
Yeah.
It's still going to match exactly, right?
Yeah.
Okay. So we want to do a hypothesis test on the sample mean. So the first thing before we do a question, we need to know that the sample mean x bar is also normally distributed. Okay. And the mean of the sample is also the mean of the population. Okay.
Oh, it's the same thing.
Yeah. But
Okay.
the variance of the sample mean is sigma squared over n.
Okay.
Yeah. It's just
What's
something you
the
have to
n?
memorize. N is the number of the sample size.
Oh, okay. Yeah.
Cool. So if we have if we have a variable x, which is normally distributed with the mean and variance, then the sample mean for that thing also has a normal distribution. Okay.
Yeah.
With mean mu as well, but the variance is sigma squared over n.
Okay.
Yeah.
So the only difference is the over n.
Yeah. So for example, this one, we have xn 450 25 squared.
Yeah.
So for the sample mean, we have x bar n 450 25 squared over 10.
Yep.
Okay. For this one, we have xn 4215 squared. So for this one, we have x bar, because it's the sample mean, n 42 as well, 15 squared over
2.
20.
Oh, yeah.
Okay.
Yeah.
So let's do a full hypothesis test.
Yep.
Start off by looking at the variable. So we have x n 177 squared. Okay.
Yeah.
Then we have a sample mean. So the sample mean is also normal, 177 squared over 5, because it's just a sample of 5 male students instead of every male student.
Yeah.
Okay. So the mean was meant to be 170, yeah? So
Yeah.
we have to do a null hypothesis where the mean is 170. Okay?
Yeah.
That's what we think it is. We thought it was. Okay? So
Yeah.
every male student has a height of 170 centimeters.
Yeah.
But the new one is 174. Okay. So we're wondering, has it increased? So was that just like it happened in a small sample that can happen? So if you have an average of 170 and you pick 5 random people, it can be 174. That's not that deep, is it?
Yeah.
The average can still be 170, but you pick 5 people and it'll be 174, right?
Yeah.
Or should we change the mean and make it bigger? Okay.
Okay.
Cool. So we have to pick our extreme outcome, which is 174, and we have to test the probability of that happening. So we have to work out the probability that x bar was more than or equal to 174.
Yeah.
Okay. So we do that using back to basics, normal CD. Okay.
Yeah.
Mean as 170. Sigma as, what would the sigma be? The standard deviation.
It's just 7.
We're using this one. So it'll be square root 7 squared over 5.
Square root 7.
Yeah, because we're doing it for the sample mean now. So the variance of the sample mean is 7 squared over 5, right?
Yeah.
So the standard deviation is square root of 7 squared over 5. So it's 7 over root 5. Okay.
Yeah.
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 Okay. And then the upper is a very, very big number. And the lower,
174.
174.
Yeah.
Okay. So we get an answer of, can you check? Can you calculate? And you get 0.100. Okay.
Yep.
0.10 is more than 0.05. So do not reject HO. Okay. So that's another thing.
What does that mean then?
If the probability is more than the standard deviation, if the probability is more than the significance level, then do not reject H0. You can either, and if it's less than the significance level, then reject H0.
Okay.
And just state that there's enough evidence or there's not enough evidence.
Okay.
You can memorize that.
Yeah.
Okay. It will be in the notes, but you can also try to understand it. So if the probability is high, it means that thing which we were scared about is actually normal. The probability is high enough. We don't have to be scared about that. Yeah, the
Yeah.
fact that they were 174 centimeters tall. If the probability is very small, then that means our old model did not work. We had
Oh.
a crazy result. So we should adjust the mean.
Oh, okay. So HO is the original one, 170.
Yeah.
Okay.
So we can stick to that.
Cool.
Okay.
Yeah.
Cool. So let's do another one. So we have x n 130 12 squared. And then we have a sample mean. We have x bar n 130
Let's go with
12 squared over the number in the sample
is it
10.
oh
Yeah.
yeah.
Okay. So in this case, it's an easy number. 12 squared is 144. 144 divided by 10 is
14.4.
1.44. Oh, sorry. Yeah, 14.4, sorry. Yeah?
Yeah.
Okay. It was only no, the thing we found was 138. So we're trying to see if it's increased.
Yeah.
So HO, the mean was 130. H1, the mean has increased.
Okay.
So we test the likelihood of the 138 thing. So we go the probability that
Like
X.
130.
No, that one's fine. But now we're just so
Oh.
that the mean has increased.
Oh, it just has to be more than 130.
Yeah. But
Okay.
we're testing the probability of 138 or more.
Okay.
Yeah.
Yeah.
To see if we should change the mean.
Yeah.
So we do that using normal CD, mu as 130, sigma as square root 14.4, lower as 138, and upper as a big number. Okay.
Cool. Is it very small?
What did you get?
0.017.
Yep. So 0.017. And then we compare to the significance level. So 0.017 is less than 0.025. So enough evidence to reject HO. Okay,
Yeah.
cool. One more. So we've got x n 8,500 and 2,000 squared. Okay.
Yes.
Then we've got the sample mean n
8,500.
Yep.
2,000 squared over 20.
Good. And then their mean in the 20 was way higher. Okay.
Yeah.
So we want to do HO. The mean is 8,500. What do I put for H1?
The mean is 9394.
Right, the mean
Oh
has
no, more than
increased.
8.
Yeah.
Yeah.
And then we work out the probability of what?
Of x being 9394.
Or more.
Yeah.
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 Because it's like more that or more extreme. So if it was lower than 8,500, we'll do less than or equal to.
Okay.
Okay. Using normal CD, mu as 8,500. What's my sigma?
It's 2,000 squared, root 2,000 squared over 2,
Over 20.
over 20.
Yeah. So 2,000 over root 20. Or root 2,000 squared over 20. Same thing.
Yeah.
And then we just put lower as 9394. So we get 0.022, 0.0228. We have to compare it to this. 0.0228 is less than 0.025. So reject H0. Enough evidence. Okay,
Yeah.
cool. The only way you can get it is just by practicing 5 or 6 in a row.
Okay.
The last part of the topic is also really weird. Okay, the first time you see it, it's weird, but once you get it and memorize it, it's easy. We've done binomial distribution and we've done normal distribution. We can use a normal distribution to approximate a binomial distribution.
Okay.
Okay, binomial is when it's success or fail. We can use a normal to approximate that.
Okay.
In the formula book, you're given 2 formulas. Okay, from a binomial, the mean is n. Okay, well, let's start from scratch. So binomial is x, b. What do I put in the brackets?
The probability
Yep,
and the n.
np.
Yeah.
Okay. N is the number of trials, p is the probability of success. Yeah.
Okay.
And for normal, we do x, n, what?
Mu and sigma squared.
Good. So if we want to work something out using a normal, we need mu and sigma squared, right?
Yeah.
So if we're only given this and we want to do this, we have to use the formula. Okay.
Okay.
Mu equals np. Yeah. You're given that in
Yeah.
the formula book. And then sigma squared is np1 minus p.
Are those are just the equations?
Yep, and you're given them.
Okay.
I'll show you where you're given them afterwards
Okay.
because you're gonna have to look for it. Okay.
Yeah.
But yeah, you're given them. So I'll show you how to use it now. We just have to do 2 questions. It's kind of easy. So it says we've got a binomial distribution because it says we've got a random probability distribution and it says B. So that means
Yeah.
it's binomial. Okay.
Yeah.
So n equals 160, p equals 0.125, and it says using a normal, it will tell you to use a normal approximation. Okay.
Yeah.
So we got if x be 160, 0.125, then x is also normal with mu and sigma squared. Okay.
Yeah.
So mu is np. So we do 160 times 0.125. Okay.
Yeah.
160 times 0.125. That's 20. Okay.
Yeah.
And sigma squared is np1 minus p. Okay. So that's 17.5. Okay.
Yeah.
I could write my working out as well. I should. So that came from doing np 160 times 0.125.
Yeah.
Okay. And then that came from doing 160, 0.125, 1 minus 0.25, 125. Yeah, NP 1 minus P. Okay,
Yep.
cool. So this equals, wait, no, not that. Then we can answer the question. So P 18 is less than X is less than 25 equals, so we use normal CD, yeah,
Yeah.
lower 18, upper
25.
25, sigma as root 17.5, mu
20.
as 20. But there's one more thing you have to memorize.
Yeah.
Okay. If it equals 18, then you don't write 18. Okay.
Yeah.
You have to write 17.5. Okay.
Yeah.
And if it doesn't equal 25, we don't write 25.
Is it 25.5?
24.5.
Oh,
Yeah.
yeah.
Okay. And then you do it in your calculator. So we get lower as 17.5, upper as 24.5, sigma as root 17.5,
Mu is 20.
mu is 20, and we get 0.584. This is called continuity correction. Okay.
Yeah.
So the steps we had to do NP equals the mean and NP 1 minus P to get sigma squared.
Yeah.
Then we do the question as normal, but when we're doing the upper and lower, we have to use continuity correction. Okay, so now I'm going to show you how to get the continuity correction, and I'm going to show you where to get the formula. Then we'll do one more question. So if we go to A-level stats, so page 20. And we look at binomial. In the table there, it says the mean of a binomial is NP.
Yeah.
And the variance of a binomial is NP 1 minus P. So you go to stats, page 20 or so, and you look for that. Okay.
Okay.
Cool. That's when you're approximating
Yeah.
the binomial using the normal.
Yeah. Cool.
Or in general, if it says work out the mean of a binomial, you just use that formula. Okay. These are the continuity corrections. Okay.
Yeah.
So if it equals A, you do 0.5 to the left and the right of it. If it's less than A, you need to not do that number. So you need to subtract 0.5 from it.
Like what we just did. We subtracted.
Yeah. We did
Yeah.
both for different, so the main thing to remember, it's easier if you think about it like this, right? This one's the most important. If it's less than or equal to, then we're including the A. So we're adding 0.5 to it. And if
Okay.
it's more than or equal to A, we also want to include the bits just a bit below it as well. So minus 0.5 from it. I think that you can note down this table, basically, take a photo of it. But the best way is just when you practice it 4 or 5 times, you'll just notice.
Okay.
So let's do one more. So we have X, 30% are vegetarian. So X is B, okay?
Yeah.
The probability, it's NP, right? So N is 30, no, 80
Yes.
orders. 80 orders. That's the N.
0.3.
That's the sample size, and P is 0.3. Okay.
Yeah.
But we need to make it normal now. Okay.
Yeah.
So the mean is NP. So 80 times 0.3. And the variance is 80 times 0.3 times 0.7. Okay.
Yeah.
So then we get 80 times 0.3. So 224. And then 80 times 0.3 times 0.7. 16.8.
Yeah.
And then it says work out the property that'll be more than 30. Okay. Px is more than 30. Okay. So we use normal CD. So we're going to do the upper as a really big number. And the lower has to be either 30 or 29.5 or 30.5. Okay. We don't want to include 30. So if you picture a number line, okay. So that's a really big number. And we have 30. It's not equal to 30, it's just more than 30.
Yeah.
So would it be better to have 29.5 or 30.5?
5.5.
Exactly. And then the answer is 0.056. The last question. So we'll do X, B, 0.25 as the probability of success. Oh wait, N and then P.
Is it 60?
Yeah, good. 60. Then we do xn, and then the mu and sigma, right? Sigma
Yeah.
squared. So mu is NP, so 60
It's
times
15.
0.25, exactly. And then sigma squared is 60 times 0.25 times 0.75. Which is 11.25. Cool. Then we work out the probability that it's more than 13, but less than, wait, no more than 18. So less than or equal to 18. Okay.
Yeah.
I can see why that would confuse people.
Uh,
So we do normal CD, mu as 15, sigma as square root 11.25.
yeah.
Okay, what would the upper be? And so let's do a number line. Okay.
Yeah.
So we got 13 and we got 18. We don't want to include 13. So do I pick 12.5 or 13.5?
13.5.
Exactly.
Oh, I think I understand it now.
Yeah. Just do a number line in your head, or if you
Yeah.
need to draw it. And we do want to include 18. So do I put 17.5 or 18.5? We want to include 18. So do I put 18.5 or 17.5?
18.5.
Yeah. Why did you bug out?
Because in the number line, 18.5 isn't in there.
Oh, okay. So you want to go a bit more to include it and a bit less to not include it.
Okay.
Cool. And then we check the answer. So we're going to go 13.5, 18.5, 25. We get 0.524. Nice, good.
Cool.